Hi there, it's physics or physical science coach Powers, and we are about ready to dive into motion and forces. Okay, so we've been talking about motion with velocity, acceleration. Today we're going to get into something which is called force. Okay, so let's explore this topic today. Today we're going to be defining force, identifying different types of forces, and then describing the potential effects of applying forces to objects. All right, so what are our fundamental forces? You've heard about some of these forces. Maybe you've heard about all of them at this point. Gravity is one of the universal forces. Okay, these are the fundamental forces of nature. We basically have four of them that we typically talk about. Gravity, electromagnetism, which includes both electricity and magnets, right? And then there are the strong nuclear force and the weak nuclear forces. Okay, so these have to do with holding the atom together, the different types and parts of the atom together. So strong and weak nuclear forces act over a very, very short distance, but extremely strong. Okay, the strong nuclear force is the strongest of all the forces. All right, and then you have the force of gravity. Now, the force of gravity exacts costs exacts a toll. The force of gravity is actually going to exert an influence, is what I was trying to say, over a long distance. Okay, but it's actually a very weak force in comparison to the others. Okay, friction is an everyday force that is the result of the electromagnetic force, and it has to do with the interplay of atoms, barriers, those little electrons. So anyway, other things to know about fundamental forces: they vary in strength. We just talked about that, and the distance in which they act. The some forces can act through contact, and some forces act at a distance. So pushes and pulls are examples of contact forces, where you'd actually have things in contact. If this hand pushes against this hand, there's contact. This is no contact, and then there's no force, no force being exerted on my other hand if there's no contact there, right? Now, when we say contact, it's oftentimes fun to talk about, whether or not, things are actually touching, and we kind of get into that when we talk about atoms. But the electrons are interacting with each other at this point. So when we talk about contact, we're talking about the electromagnetic forces actually interacting with each other, right? And so we have those as contact forces. Now, field forces don't require objects to touch each other. So, for instance, magnetism, right? The magnetic field, the electromagnetic field. You can actually see an influence of one magnet upon another without the objects actually coming into contact. Well, gravity is the same way, right? You can see an effect of gravity from objects that are not actually touching each other. But both contact and field forces cause objects to move or to stop moving. So let's talk about balance and an imbalance or unbalanced forces, right? So balanced forces will give you no net movement, whereas unbalanced forces will give you a net movement. All right, so that's kind of like the summary of it, though. So if you have a net force acting on an object, then that object is going to accelerate in the direction of the force. So if I have a pen here, and that pen has a force acting on it, if it's a net force, it's going to accelerate or move in the direction of the net force. So the net force is the combination of all the forces acting on an object. Now I'm holding this pen. At this point, it's not actually moving, right? And so there's a force that is holding the pen in place. And then it has to, in order for me to move it in that direction, it has to overcome that force of me holding the pen. So the net force is a combination of the holding and not moving, and then the pushing, which is going to end up being greater. The pushing part is, so my net force is going to end up allowing for that object to move. So remember that if it's a balanced force, there is no change in motion. So if I'm holding this and I push on it and nothing moves forward, then that's a balanced force. Okay, there's no change in motion if it's a balanced force. So the net force is zero. That's balanced forces. Net force is zero is a balanced force. For instance, if you think about a light hanging from the ceiling, why isn't it dropping to the ground? Well, gravity is trying to pull it down, and so it has a downward force of gravity, but it also has a tension force, which is in the cord that holds it up onto the ceiling, and that is balancing it out, so there's no net movement. The unbalanced forces, though, will cause movement, so they don't cancel. I don't have that gravity pulling it exactly the equal amount as that rope holding it up, right? So if I have something where it's actually slowly slipping down, then I have an unbalanced force. The net force is going to be greater than zero. And the object is going to accelerate in the direction of that force. So if I were to push a box to the east and somebody else were to push a box to the north, that box will be moving in both directions. It'll be moving in a northeast direction. So in this case, we'd have an unbalanced force. If I had two people pushing exactly opposite on the box, then that might not move. But if one changes the way that they're pushing it, now all of a sudden it's moving in a particular direction. So here we can see a couch, and we're balancing the force in the first picture, right? So the two individuals are pushing on it. The couch isn't moving because they have a balanced force. But when they're both on the same side, now there's nobody pushing back. And so now you have a force on one side, which is greater than the force on the other, which is the force of friction in a sense. So the force of friction would be preventing that couch from wanting to move forward, but they have overcome that force and the couch will start to accelerate. So to summarize, balanced forces, the net force is equal to zero. Object maintains its constant velocity. Now that could mean a zero velocity, right? So objects that are just sitting there, they have a constant velocity and their constant velocity is zero. They have a balance between their desire to move, maybe because of gravity, and the floor, for instance, which is keeping them from moving, right? So that's a balanced force, no net movement. The constant velocity is zero in this case. But you can also have that happening when you are traveling, right? So if you have something on a frictionless, railway or something, and it can move without having any other outside force, acting on it, then that thing could continue to move and maintain constant velocity if its forces were balanced, right? So net force equals zero, object maintains constant velocity. Unbalanced force is going to mean that you end up having an object accelerating in the direction of the net force. Now that's acceleration, right? So that's different than movement. So, when I talk about this balanced force and I talk about an object that might be moving in a particular direction at constant velocity, so let's say it's moving at 5 meters per second. And you can imagine this, you're trying to think of a frictionless environment. Well, just think about space, all right? So if I have this object that's out in very vast reaches of space where gravitational forces are really, really, really small, then this object could continue moving at 5 meters per second. The net force is zero, and it's not going to change its speed. It's not going to change its velocity at all. If it's just moving in a straight line at 5 meters per second continually, those balanced forces. However, if that object has a little bit, okay, we could be talking about the same object. Maybe we have a little rocket ship here, right? I don't know, maybe a little rocket ship. yeah, here's a funny looking rocket ship. And if we all of a sudden blast out a little bit of rocket fuel out the backside of it, right, then we no longer have a balanced force because now there is an action that is pushing out. And so there's a reaction that's pushing that object forward. And so now we end up having a net movement. So this would be an unbalanced force. Anytime you have a net force greater than zero, then it's going to accelerate in the direction of that. Now, friction is the thing that we really talk about the most when we talk about what's going to prevent an object from moving. And so friction, typically when we think about it, you rub your hands together like that, you'll get some heat coming from your hands rubbing together. That is going to be as a result of friction. All right, friction is the force that resists the motion of an object due to the surfaces coming into contact or rubbing against each other. Okay, so now this is due to intermolecular forces or collisions that might be taking place. There's attraction between the electrons of one hand and the atoms, the nuclei of the other, between my skin cells, right? And so if there is ridges on your fingertips, right, you wonder what fingerprints are for. Well, one of the reasons that they say fingerprints are probably good for, and one of the reasons that they have a function in a human body is to actually help you to hold on to things because they give you a little bit of friction there, right? So you think about a fingerprint, what would it be like if it was smooth, right? If you had like, maybe your skin like on your arm or something, it doesn't have a fingerprint, would it have the same amount of friction as your finger? I don't think so. So fingerprints are actually great for helping you to hold on to things. And if you think about lizards and geckos that can kind of climb up walls and stuff, they actually have a texture that allows them to adhere to surfaces because of the intermolecular forces that are there. Now, what kind of intermolecular force are you dealing with there? You're dealing with something called static friction. And that's a force that resists sliding motion. Okay, so static friction is present when things are static. Static or stasis, right, means it's not moving, it's stable. And so here we have this static friction where it's staying in one place. And in order for it to start to move, you then have to overcome static friction. Okay, so static friction is the force that resists the initiation of sliding motion between two surfaces that are in contact and at rest. So in order for static friction to be present, it needs to be stopped, right? It's not moving, all right? And then once it starts moving, you've overcome static friction. All right, kinetic friction, though, is another type of friction that is present. Now, static friction is a greater friction than the rest of these other frictions, all right? Kinetic friction is a lesser type of friction than static friction. There are three types of kinetic friction that we're going to talk about right now, all right? So kinetic friction is a friction that's in play when things are actually moving. Once you've overcome an object that is stopped and it's now moving, it's easy to move it. And you can do this with a block of wood on another block of wood or something like this, and weight on it and get that thing to start moving. It actually takes a little bit to get it going, but after that, it seems like it slides along pretty easily. Because sliding friction is a much lesser friction than static friction, because it doesn't have a chance to, have that attraction, that bonding that's basically occurring. Now, we don't really want to say bonding. We've tried to say attraction here, but the intermolecular attractions, those forces that are at play when something is still, are going to be greater than when something is moving and it can't get a chance to stop and get that connection, okay, that attraction. So we have static friction, which of course you can see has been overcome. There we go. So the idea here on this one is that we do have some motion, right? And so static friction has already been overcome. So what we have now is sliding friction. Now, sliding friction is going to be basically a force that is moving in this direction, okay? So the motion is here in this direction, but the friction is basically described as going in the opposite direction. Now, rolling friction is a friction that's even less than sliding friction, and this is why wheels are great, because you don't have to rub up and try to drag something across a surface. Each little contact is only in contact for a little while until it peels away, right? So if you are applying a force to the wheel in this direction, then your friction that's resisting the wheel's motion is going to be in that direction, all right? But rolling friction is less than sliding friction typically. And then, so that was rolling friction. And then you have fluid friction. Now, fluid friction is going to be a friction that you might have fluid friction. Fluid friction is going to be a friction that you would have in a liquid or a gas. Okay, and so if you have an object that has drag, you guys have heard of drag in an airplane or maybe in a boat, right? That drag, that's those little particles coming in contact. And so, yeah, those little particles are going to come in contact for a little while with that surface of the boat or the airplane. And so it's going to cause some drag. It's going to slow that thing down just a little bit. So fluid friction is a friction as well, but it's also very, very much less than sliding friction, for instance. All right, so why is friction a good thing? You're like, well, it's always stopping things. Well, that's a good thing. We want friction to be able to stop things or to slow them down, to allow you to, for instance, grab onto things, right? Like, how would you ever write if you had no friction? Like, I can't hold on to the pen. Bye-bye. So that is why you need friction, all right? It's necessary for everyday tasks to work correctly. Now, sometimes you're going to have too much friction. Like, for instance, in a car. If you had too much friction there, car engine might heat up. That would be bad, right? So we can lower what friction is if we do things like apply oils to them, for instance, right? If we can apply a nonstick coating to a cooking pan, for instance, or lubricants to various objects, we can prevent those things from sticking to each other as much, and so they'll slide a lot better, all right? And you can also try to increase that friction if you need to in certain situations. For instance, can you imagine if we had roads that had no friction? Well, it's kind of like on an icy day, right? If that road gets really icy, then you're not going anywhere, right? And if you do get going, then you're not stopping very easily. So we can increase friction by adding salt or sand and things like that to try to give you a little bit of traction. Putting chains on your tires, increase that friction, and you're going to keep from skidding. Things like sports are oftentimes using friction to help people play the sport better, right? So you can think about a batting glove, right, to swing that bat. In baseball, that's going to help you to grab onto it and have better control. Even things like the textures of various balls. Like think about the texture of a basketball or football or volleyball. Why do they put those little ridges and those little bumps and things like in that? Well, that's because you want to have better friction so that you can grab onto it better and hold it better and control it better. So friction's very good. Friction's very good. Cars wouldn't be able to move without friction, right? Tires wouldn't be able to get a grip and push against the road, so the car would never be able to move forward if you didn't have friction. Remember that the force pushing the car forward must be greater than the force of friction that opposes the car's motion in order for it to move. So where does that force come from? Well, that force is coming from the engine that's applied through the tires, right? It's allowing it to turn those wheels and get that thing going. So in order for the car to keep moving, though, at a constant speed, you always have to apply more force. Like if you took your foot off the gas, that car doesn't keep going. Why? Because there's friction, which is pulling on that car all the time and trying to pull it in the opposite direction of your motion. So the engine is making your tires move and making that car move in a particular direction. As soon as you take your foot off the pedal, then the engine's no longer applying that force. That means the car is going to slow down because of friction, right? Which is, again, it's a good thing. All right, so if you look at this car here on the left, you have a balanced force where you have constant speed. But in order to maintain that constant speed, you have to continue to apply gas, right? Which is kind of strange. You're applying a force to maintain constant speed. If you had a zero friction environment, then you could maintain constant speed with no added force. But this is a balanced force. My force forward, what I'm putting under the gas, is balancing with the force backward, which is the friction that's just trying to slow down the car. If I want to accelerate and I want to go forward, then I'm going to have to apply a greater force. I'm going to have to get that engine to move even faster, to apply more energy to get that thing to turn faster in order for you to move forward. And if you look in the far example, you have the truck not sliding. Why? Because of brakes, right? We want brakes to be able to stop the car from sliding. And so that's a balanced force. It's important to realize that you actually do have forces that are pulling on you. Like in this truck's example, there is a force that is trying to pull you down the hill. And, let's say I have, 500 newtons of force pulling me down the hill. Well, what's keeping me on the hill from going down? Well, 500 newtons of balanced force is trying to keep me from going down that hill, and it's a balanced force. And so the brakes are applying that equal amount of force to keep the truck from moving. And the truck might be able to have even more force applied to it with the brakes. If I have a steeper hill, then the force might get greater, and my brakes can still apply greater force than even 500 newtons, let's say. Anyway, so cool stuff, right? We learned a little bit about forces, and let's look at our review. Let's see if we understand what forces are. Can we define a force? Right, so the force is going to be defined as, a push or a pull, typically, that is going to cause motion, right? So some sort of action that is going to, or force that is, application of action that is going to either cause motion or be balanced and no motion will take place. Identify the types of forces. Yeah, so we've talked about our different universal forces, right? So gravitational, electromagnetic, strong nuclear, weak nuclear. And then we talked about the things that are pulling against those forces, right? So we have the frictional force. We had first of all, static friction, and then three types of kinetic friction: the sliding friction, the rolling friction, and then the fluid friction. So I've covered a lot of good stuff today, and hopefully quick and easy. And now know a little bit more about the world of physics, and I hope you can now think about the world in a great way and appreciate friction. Look at all the things that are on your desk and how they're not moving, and think that is great, because they would be moving off my desk if there was no friction, and that would be a crazy world to try to live in. I wouldn't be able to sit in the seat if I didn't have friction. So yay, friction! All right, well, I hope you have a great day. God bless you guys, and be kind to one another.